doing, but then also do a little preview of the stuff that we're going to do. It's really the same applications of what we've done, like the same steps in the process of applying Newton's second law, but it's just going to be a little bit different. And that way you'll be ahead when we get to the incline plane, which is going to be kind of a big part of your exam next week. But if you have other things that you want to look at, projectile motion, vectors, the 1D problems that we've done, we can spend some time on that as well. Are those some of the things that you would like to look at, or do you want to jump right into the incline plane? Yeah, so we can do both, that's sure. So we'll have projectile motion. One of your free response is going to be something like number 2, where I ask you, actually not like number 2, like number 3, where you're finding the horizontal range of the ball, or I might ask you the vertical range of the ball. Okay, so on these, yes, you want to look at this? Yes, it'll probably be a free response problem. It will be a free response problem. So your free response will probably be a projectile motion and then an incline plane, both of those. So it's a big part of your exam. So 2 and 3 are part of the same problem. I'll draw a figure over here, but really we're looking at number 3. But we'll answer both. So I have an object. It's at an angle of 60 degrees. My initial speed is 32 meters per second. And I want to know a couple things. I want to know what is the speed at the top. And then I also want to know what is the horizontal range. What is x? Now to find the horizontal range over here, I know that I need to know Vx and I need to know t. Those are one of my kinematics equations for projectile motion, which remember there are really only 2 equations. I just apply where ax is equal to 0 or ay is equal to -10. So x is equal to Vx times t. So a couple things I need to do in order to find out this range. One, I need to find out the time. That's sort of the hardest part. And then I need to figure out what Vx is. So find the time. In order to find t, we need to go back to that problem that we worked for the last test, where I have an object that goes up and then comes back down again. It's the same problem. Okay? In order to do so, I need to find what is my x and y components of my velocity. Vx is equal to 32 cosine 60. That's equal to 16. And then Vy is 32 sine of 60. And that's 28 meters per second. So this problem, I have 2 vectors. One is 16 meters per second, that's my Vx, and 28 meters per second, that's my Vy. So that Vy is going to be what I use to find t, because remember your y motion determines the amount of time that the object is in the air. So this is just like I'm just taking an object, I throw it up, it comes back down again. Remember to find the time, we use this little trick that the velocity at the top is equal to 0. And if we do that, then I can calculate what is the time that it takes to go just up to the top. And then I'll double that in order to figure out what is the total time. So let's go ahead and do that where I'm working this problem to find the t. I say that v at the top is equal to v naught y plus ay times t. V top is 0. V naught y I know is 28. That's what I had right over here. Minus 10 times t. And then I solve that for t. Subtract 28 from both sides. Divide both sides by -10. So t is equal to 2.8 seconds. That's my time. But that's the time to get to the top. So really the total time is times 2, or 5.6 seconds. Now I'm almost there. Once I do that, I'm almost done. X is equal to Vx times t. And so that's going to be Vx, which is 16. That's right here. Times 5.6 seconds. That's the total time that it's in the air. I get 89.6, or 90 meters. So it's going to be that answer right there. Can I step back through what we did here? Oh, and by the way, I can answer number 2. What is the answer to number 2? The top of the trajectory, what is the speed of the ball? No, it's not 0 because it's 0 in the y direction. You're right about that. That's what you're thinking. But in the x direction, it's not 0. It's 16, right? So the answer to number 2 is 16. Look, that's going to be one of your free response. Right? We didn't have to do that much on the last test, right? No, yeah, that'll be a free response. It'll be that kind of question. And there'll be 2 or probably 3 questions buried into that whole thing. How long does it take for the trajectory to complete the trajectory? How high does it go? What is the speed at the top? What is the range? You need to know that problem backwards and forwards. It's going to be the very first problem. I always find that when I'm taking an exam, if I do well on the first problem, it just sets a good tone for the rest of the exam. I'm much calmer. I just sort of know what's going on. So it's really important that you know how to do this problem for the exam, because it'll be problem number 1. And it's going to be worth about 3 or maybe 4 questions. Okay? Practice, practice. Every exam has a problem like this. It has several, so make sure you practice them. So let me just step through. First thing I do is I recognize that this is a problem where I'm beginning and ending at the same height, and so that affects how you approach it. Remember, there were 3 types of problems that we had. This kind, where I'm shooting off from a horizontal, and then where I'm shooting off from a height at an angle. And this is the first. This is probably what's going to be on the exam, on the free response, rather. They'll all be on the exam, but this one will likely be the free response. I find the x and y components. I'm going to need them, so I'm going to go ahead and find them. And then I have to figure out the time. And the time is just that problem we did on the last exam, the one that was free response, where I'm imagining an object that's just moving in the y direction. And so I say that Vy at the top is 0. I can use that fact to find the total time, and then double that time. Excuse me, I can use that fact to find the time at the top, and then double that time in order to find the total time. Okay? Yeah? We go okay? We worked a bunch of different problems like this, but if you're not getting them yet, I know that some of you aren't, you need to practice, practice, practice. It'll help. Even if you just sort of feel completely lost, the more that you practice these, if at first you have to use the videos to sort of help you nudge along, that's okay. But eventually you want to be able to do it all on your own. All right. Let's look at it. There are some other different types of projectile motion problems, but I want to look at a force problem. We're going to get to this stuff later. Like a 1D force problem. Let's look at 20. This one's a little bit different than what we've seen before. But you need to be practicing these, okay? You need to be practicing them this week, especially so that as you move into next week, you probably have other things. Make sure you're working, probably doing 10 of these a day, and make sure that you master them. So a woman who weighs 700 newtons steps onto a scale that is in an elevator, and the elevator begins to accelerate. The woman now weighs 500 newtons. The acceleration of the elevator is what? This is kind of like the problem that we did in class, where I have an object that's suspended by a tension force. Remember, we did this problem, and we said, well, there are 2 forces. There's the tension, and then there's also the weight, the actual weight of the person. In this case, the weight is given. But it's a little bit different, because this problem, well, the way that you solve it isn't different. This problem is actually a lady. She is our FW. You can imagine her being like a block. And then there are 2 forces acting on her. There's the weight, FW, and then there's a force. We're going to call it the normal force. We're going to see this in class tomorrow. We'll define the normal force. The normal force is a lot like the tension. You sit on the floor, you sit in your desk, you have a weight pushing down, there's another force pushing up. Okay? That's the normal force. Normal just means perpendicular. So that force is always perpendicular to the surface. So in this problem, it's different from what we did before because I know the weight is 700 and I know the normal force is 500 newtons. That's how much she appears to weigh, and I'm asked for the acceleration. Now, is she accelerating up or down?
Down.
Why is she accelerating down?
Because she's losing weight.
Yeah, because she feels lighter than she is. It's like you get into an elevator, and if it goes up, it's like you feel like you're being dragged down. It's like you feel heavier than you actually are. But if it goes down, it sort of feels like you're lifting up off your feet a little bit, that you feel a little bit weightless or a little less weight than you were. Have you ever been in a really fast elevator in a tall building? So I know right away that she's accelerating downwards, so I can get rid of C and E. I'm going to get rid of C and E. Oh goodness, I can get the right answer just without even working this. What other answers can I get rid of? What does it mean to be in free fall? What is your acceleration if you're in free fall?
Gravity.
You're accelerating at the rate of gravity. And if you're in free fall, what is your weight, your perceived weight, if you're just falling through space? No weight at all, right? Like you feel weightless. That's what weightlessness is, that you're in free fall. When the people are in the space shuttle and they feel weightless, they're weightless. It's not like they don't have any mass. It's just that the space shuttle is continuously in free fall towards the Earth. But because it's traveling around the Earth in orbit, then it never falls to the surface of the Earth. It's just like it's continuously falling towards the Earth, but it goes around the Earth. So I know that it can't be B, because that would be free fall. That would mean that her normal force would be 0. What else do I know it can't be? It's either A or D. Which is it? Want to venture a guess? Huh? You think it's A?
I'd say it has to be A.
Yeah, the answer is A. The answer is A. So the answer here is A. Because D would be like free fall plus some, right? Plus more. Let me show you how you get that. So what I've done is I've drawn the free body diagram. Hopefully on an exam you get to stop there. It's like, I know the answer is A. I'm just going to move on. But I draw the free body diagram. I'm going to apply Newton's second law, which is just sum of the forces equals M times A. The sum of the forces is 500 minus 700 equals the mass. Do y'all know the mass of this lady? Look, if F weight is 700, that's equal to M times G, which is 10. So that means her mass is 70 kilograms times A, and then A is what I want to find. So A is equal to minus 200 divided by 70, which is 2.9 down. It's negative 2.9, but the negative means that it's downwards. Okay? You with me on this, folks? That question will also be on the exam. Probably not free response, but something similar to that, a 1D problem, probably an elevator type problem, where you have to apply Newton's second law in a one-dimensional problem. Okay? All right.
What test is this from?
Huh?
What test is this from?
Oh, this was, I think this was 17. Let's see. Yeah, fall 17. All right, we're going to get to friction. I'm not going to do any friction right now, but I do want to do an incline plane. We can do this one. This is number 25. And some of this is going to be a little bit different. In fact, I'll give you a little bit of a preview. Is it okay if I do incline plane? It will help you. You'll be at an advantage when you come into class tomorrow. We'll probably get to it tomorrow. You ready? Okay, so incline planes. Look, if I had an incline plane, I describe it by an angle right here. We'll say that this angle is 30 degrees. And imagine if I have a block. It has a certain mass. The first thing that I would normally do is draw my coordinate system. And I might draw it like that. But if I do that, we're actually not going to draw a coordinate system like that. But let me show you. If I do that, I get some forces that are acting on this object, I'll get the force weight that is acting down like that. But then my normal force, that force like the lady that was in the elevator, the floor of the elevator was pushing back up on her, the normal force is always normal to the surface, and normal means perpendicular. And so my normal force would be in this direction. And then if I had other forces, for example, if I had a frictional force, this problem doesn't have any friction, but if I had a frictional force, the frictional force would be in this direction. I'm going to label that with a lowercase f. I'm going to put in parentheses because we haven't seen this friction. Probably Monday we'll get to that. And then, not only that, but this object is going to be accelerating down in this direction. So I want you to notice that we have one force that's on the y-axis here, two forces that aren't on the y-axis, aren't on any axis at all, and then I also have an acceleration that is going along this line. And so this coordinate system doesn't work very well for us because it only gives us one force or vector on axis, but then we have one, two, at least three others that are off axis if you include the acceleration, which you do. So the best way to do the coordinate system for these inclined planes is going to be like this. Okay? Now, I'm going to draw my vectors on here, kind of like I did before. My weight looks like this. That's FW. And I know that this is 1 kilogram, so I know that my weight is 10 newtons. 1 times G is 10. 1 times 10 is 10. And then I have another force here, which is my normal force, Fn. There's no friction, so those are the only forces that I have acting on this block. Remember the 3 steps? I do my free body diagram. That's just the picture with the coordinate system and all the forces that are labeled. What's the second step? Starts with an R. Resolve the vectors. So resolve all the vectors in their x and y components, and then apply Newton's second law. So I have a vector here that's not on the x or y axis. I know that this angle is 30 degrees. It says it in the problem. And the angle that you'll use, that you'll need to use, is the angle that's measured from the x-axis. And that angle, if the triangle is 30 degrees, what is that angle?
60.
It's going to be 60. Notice that there's a triangle here, here. And so if this angle is 30 degrees, this angle is 60 degrees. People do this differently. Okay, in fact, I've done it differently on past exams, that sometimes I use the 30 degrees and sometimes I use the 60-degree angle. But I found for students it's a lot easier if you just use the 60-degree angle. So then your x and y components are still the same. So just nod and say, okay, it'll make your life a little easier. So whenever you're dealing with these inclined plane problems, I want you always to figure out what is this angle. And it ain't that hard. You just say, well, 90 minus the triangle angle, what's that called? Like I don't know, the 30-degree angle is equal to 60. Okay? So I'm going to redraw this. With my resolved vectors, I have Fn, I have Fw cosine of 60, and I have Fw sine of 60. Okay? And I want to know what is the acceleration down the inclined plane. This is where I apply Newton's second law. This is step number 1, step number 2, and now I'll apply Newton's second law, step number 3, where I say the sum of the forces is equal to ma. Now in the inclined plane, for an inclined plane, ay is always equal to 0. Because of the way that I draw my coordinate system, your object is never going to accelerate in this direction. It's just never going to do that. That's not how it works. So I'll always have ay is equal to 0. It turns out in this problem, this is one of the simpler of the problems with an inclined plane, that you don't need to do anything with the sum of the forces in the y. Because all I want to know is what is the acceleration. So I'm just going to look at the sum of the forces in the x direction so that I can find ax. This is what I want, because I'm looking for the acceleration of the object. And since the acceleration in the y direction is 0, if I find ax, that'll be all of the acceleration. That's the beauty of rotating your coordinate system, that your acceleration is only along the x-axis, none in the y-axis. But if we had used this coordinate system over here, notice we'd have a component ax and a component ay. And you can work that problem, but it becomes a lot more difficult. Okay, so some of the forces in the x. It looks like I just have one force. I have minus Fw cosine 60. Why did I do minus?
It's in a negative x direction.
Right. Not because it's down. Right. It is sort of going down the inclined plane, but that's not why I did negative. I did negative because it's in the negative x direction. That I have positive x here and negative x here. I tell you that because sometimes you'll see an inclined plane that's not oriented like that, but it's oriented like this. And I want you to notice that when I do my coordinate system here, I have negative x up the inclined plane and positive x down the inclined plane. So be careful with your coordinate system, that you're just following the normal Cartesian coordinate system, that you're not getting all hung up on what's up or down. Up is not necessarily positive on the x-axis. But in this case, in this problem, it is, as you would expect, negative is down. But doesn't have to be. So negative Fw cosine 60 is equal to max. I know all this stuff, right? I know that Fw is 10, so negative 10 cosine of 60 is equal to 1. That's my mass. It was given, times ax. And so ax is equal to negative 5. So that's the answer. Okay, I know that seemed like a lot of steps, and it's still the 3 steps. But you know, the 3 steps can be really complicated. And you'll see some other problems, and we'll do some in class that are more complicated than this, especially when we get into friction. That when we put friction in your problem, it makes the y-axis becomes important now. So there's an extra step. And we'll look at some friction here in just a second. Can I step back through the steps that we did? 3 steps. You draw your free body diagram, and that involved recognizing my coordinate system needed to be rotated. And that's what I did here. I can draw my coordinate system however I want. And so that's what I did. It just makes the problem easier. That is always how you will draw a coordinate system for an inclined plane. Is that true? In this class, it's always how you'll draw it. In some special cases, it's useful to draw your coordinate system a different way. But I don't think that you'll ever encounter that. Even on the MCAT, I don't think that you'll encounter that. Okay, so I draw my coordinate system. I label my forces. I have this normal force. Remember, the normal force is normal to the surface. That means perpendicular. So even though your normal force doesn't have to be perpendicular to the earth, it's only perpendicular to the surface. So if I push on this wall, there's a normal force that's pushing parallel to the earth because it's perpendicular to the wall. Normal force, weight. Then the next thing is I need to figure out what is the angle. I know if this angle is 30 degrees, this angle is 90 minus 30, or 60 degrees. Then step number 2, I resolve my vectors. Here I have Fw sine 60, Fw cosine 60. I just broke that vector into its 2 parts and Fn. And then in step 3, I can apply Newton's second law. And in this case, I didn't need to write anything about the y-axis just because it wasn't important. It didn't pertain to this problem. I just look at the x-axis. Sum of the forces on the x, there's only one force. That's equal to max. Ax is what I'm looking for. And so I solve that for ax. Look, I can also write the sum of the forces in the y direction. They would look like this. Sum of the forces in the y equals 0. and it's going to be Fn minus Fw sine 60 equals 0. I'm just looking at this axis. Notice that my Fw, or I would keep my Fw as positive. I did that right here. Fw was 10. I have a negative here because it was on the negative x-axis. You'll follow me on that? That might not be obvious, but my Fw cosine 60 I wrote as negative because it was on the negative x-axis. But when I put in Fw, remember we use a positive g to calculate Fw. So I use 10 newtons as my force weight. Okay? I know we're going to do this in class. Now, you might be a little confused right now, but I want that to help you in class when we see that tomorrow when we start doing the incline plane. Because it will be a big part of your exam. The other free response will be an incline plane, and it will have friction on it, so it'll be even a little more complicated than this. Once you get those first two problems, they're going to count like 8 questions once you get those right, completely right. Okay? Now do that for me. It's kind of important that you get those, because like I said, it sets the tone for the whole exam. I can do it? You can do it for me, right? If I ask you nicely, you'll get it right? Okay, be practicing them, because they will be on the exam. Was that a snide comment? Okay. Let's look, here were some other questions. Like if in the previous problem, good example of an exam question. Like here's friction involved, and here's my normal force. Exam question, well, I'll break the question up into several different parts, and I'll ask questions a lot like this. What if I wanted to find the normal force acting on the block? If I wanted to do that, I would come up here. Look, I have an equation that I wrote from Newton's second law that can tell me exactly what the normal force is. Fn equals Fw sine of 60. And so that's Fw was 10 newtons, 1 kilogram times 10 meters per second squared, 10 newtons times sine of 60, 8.6. So that's my normal force, or 9 newtons. Let's look at a different friction problem. We'll come back to that. Questions? Yeah, Russell.
Those names you have on question 28, you just make those names up, or those are previous students?
No, I make them up.
Okay.
I always do it so that it's not somebody in the class. Because I don't want anybody to look at it and it's like, oh, I'm the favorite. Okay. Let's look at a friction problem. Anything in particular? Can we do a friction problem? You okay with that? Yeah. Okay, let's look at 19. It's sort of a basic. This is fall 16, I think. Yeah, fall 16, number 19. So a block moves with a mass 5 kilogram. This is fall 16. On a flat surface, and a force causes 20 newton causes the object to move with acceleration. What is the coefficient of kinetic friction? So when we're talking about frictional forces, I'm going to use the lowercase f. That's our frictional force. And what you need to know about this is that it opposes the direction of motion. In class tomorrow, or on Monday, we'll talk about the two different types of friction, kinetic and static friction. There are 2 different types of friction that are at work when objects are sliding or they're just stationary with respect to one another, and they have different values. We'll talk about that tomorrow. But for now, just know it opposes the direction of motion. So if I have an object and I'm pushing it with a certain force in that direction, the frictional force is in this direction. Okay? So if I have a 5 kilogram object and I have a force of 20 newtons that's causing it to move in this direction at 2 meters per second squared, this is 5 kilograms. If this was a 5 kilogram object with a 20 newton force and no other forces, it should be moving at what acceleration? 5 kilograms, 20 newtons. What should its acceleration be? Simple, F equals ma. It should be 4 meters per second squared. Because if I had 20 newtons, if that was my net force, and my mass was 5 kilograms, then A should equal to 4. But it's not. That means that there's another force acting on this. You might be able to guess right now what that force is. Can you guess what the force is? Well, yeah, it is. But what is the value of the frictional force? Can you guess just from looking at those numbers? Well, if a 20 Newton force would cause it to go 4 meters per second squared, but it's only going half that, it's going 2 meters per second squared, then how much is the force it's acting on? Huh? No, not 0.2, the German action. All right, let's just work it out. Okay, maybe you're not seeing that yet. That's okay. So I know that there's another force that's acting in this direction, and it's our frictional force. I know it's in that direction because it opposes the direction of motion. Nothing new here. This is exactly what we did before. I draw my free body diagram. Now I apply Newton's second law. That's step number 2, which is that 20 newtons minus the frictional force equals the mass times the acceleration. So 20 minus F equals 5 kilograms times 2. So F is equal to 20 minus 10, or 10 newtons. So that's my frictional force is 10 newtons. Now the second thing that you need to know about frictional forces is that the frictional force is equal to the coefficient of friction times the normal force. So here mu is the coefficient of friction. It's just a constant. When you have two objects that are sliding, some objects are just stickier than other objects, and they have a higher friction. Like sandpaper on wood has a pretty high coefficient of friction, but steel on ice has a very low coefficient of friction. So different objects of different materials have different coefficients of friction just based on the type of material. And here I want to know what is the coefficient between the block and the flat surface. So I know that little f, the frictional force, is equal to 10, and I also know that that's equal to mu times my normal force. So if I can figure out my normal force, then I can figure out the frictional force. Y'all know what the normal force is? Let me draw the vectors here. I have a normal force in that direction, and I have a weight in this direction. You're right, 50. Yeah, because my weight is equal to 50 newtons. My normal force is equal to 50 newtons. I know that because AY is equal to 0. Sum of the forces in the y equals Fn minus Fw. That's going to be equal to MAY, or it's going to be equal to 0. Fn minus the weight, which is 50, will equal to 0. So Fn will equal to 50 newtons. Don't worry, this will become a little bit second nature to you. That you'll be able to look at this and say, oh, this is an object on a horizontal surface, so the normal force is equal to the weight. That will become second nature to you. Don't worry, you won't have to go through all these steps every time. So if my normal force is 50, coming back over here, I have 10 is equal to mu times 50. So mu is 10 over 50, which is 0.2. Okay, that's a simpler of the friction problems, but you'll have a friction problem. You'll probably have one something similar to this, but you'll also have a friction problem where it's on an inclined plane, and that'll probably be the most difficult problem on your exam. But we're going to spend time in class working them, and I want to give them to you now so that you're just have time to begin preparing for it, because it's going to take you at least a week to get this to be second nature for you. And that's what you want. You want it to be second nature. Okay? What else can we work through? Those are the two big things I wanted to get through, inclined planes and the projectile motion. What else can we work through? You want to do a vector problem? Or, let's see. Is this overwhelming to you? Overwhelming? It's a little bit overwhelming. I know that it is for some of you, for most of you, in fact, because you've just never done this before. It's different. Let's see. Can we do another inclined plane problem? Yeah. It's good for you to see it. Okay, it's like taking your medicine. It's good to do it. This one has no friction, so that means that it's a little bit easier. So the first thing that we do is we draw our coordinate system. Then we draw our forces. I have FW right here. I know that FW is equal to 20 newtons because look, the mass is 2. That means the weight is 20. I have another force that's acting in this direction. I'm just going to call it F. That's the force of the rope, or I'll call it FT for tension. And it's the tension that I'm looking for. I want to know what is the tension. And then the other force that I have is the normal force. I'm told that the acceleration is equal to 1 meter per second squared. Oh, it's up the inclined plane, but be careful, that is a negative acceleration because it's in the negative x direction. Now, I need to recognize that this angle is 60 degrees because this angle is 30 degrees. 90 minus 30 is 60. That was step 1, you know. Step 2, I resolve my vectors. Just redrawing them. You might not have to redraw them on the test, but I find that it's useful. In fact, one of your questions on free response might be to just label all the forces that are on this. I might force you to do a free body diagram. I haven't written it yet, but so there's Fn, there's Ft, and then I got to resolve Fw. That's going to be, I'm going to go ahead and put numbers in here. 20 cosine of 60, and then 20 sine of 60. Okay, so now I'm looking for the tension. So I know that to find the tension, I'm going to have to look at this axis. So I'm going to apply Newton's second law. This was the second part. Now the third part, sum of the forces in the x direction is equal to max. I know Ft. I know the x component of the weight. Do I know what ax is? Do I know ax? Right, and it's -1. So this is a straightforward problem. I don't have to do anything with the y-axis. There's no system of equations. It's fairly straightforward to solve. The sum of the forces in the x is 20 cosine 60 minus Ft is equal to the mass, that's 2, times ax, which is -1. And then I solve that for Ft. 10 minus Ft equals -2. What's that? Ft equals 12. So A is the right answer. I subtract 10 from both sides, multiply both sides by -1 to get positive 12. Okay? If you had not used -1 for your acceleration, you would have gotten this problem wrong. Because notice, if I have this not as -2, but as +2, when the 10 comes over, I would get -Ft equals -8 instead of -12. And then you would have had Ft equals 8. Oh, I didn't put 8 on here, but I should have. I really would have. I don't know why I didn't. But even if you thought it was 8, you probably would have put 10 for the answers. You wouldn't have put 12. Unless you'd gone back previously to the problem. Okay? Anything else today? I want to call it a day or more here. Because this second exam is important. The first exam was important, but the second exam is like you're thinking about dropping. This is the exam that you need to really excel on. You need, because if you don't do well on this exam, I'm gonna say we need to retake this class. Like we need to come back with a fresh start. If you did poorly on the first exam, I'm not worried about that. But you gotta pick it up in the second exam. That's very important. You made a 30% on the first exam. I'm not worried. I don't look worried. But you gotta be better. You gotta make it see you're better on the second exam. Okay? All right, y'all. Have a good day, okay? Thanks for coming. I'll see you tomorrow. We'll do more of this tomorrow, but y'all be experts by tomorrow.